Hello everyone, welcome to Legacy IAS. So today we'll be learning about cuboids. Okay, so now cuboid, first of all, how is it different from cubes? So basically, as you would know already, that cuboids have different side lengths. So for example, in cubes you have length, breadth and height all of same length. Length, breadth and height all were of same length. Correct. In cuboids, what you will have different lengths, different breadths and different heights. For example, if this is length, clearly this is not equal to breadth and very clearly not equal to this height or depth. So basically all three dimensions are different in a cuboid. Now, let's see, same questions are there. So basically what they do, this is a bigger cuboid now. Okay, now this also they will cut into similar pieces of small cubes, usually of 1 centimeter cube. Now then they will ask you number of cubes with one side colored, no side colored or something questions related to that. Now how do you expand it? Let's first understand this. So whatever are the formulas that you had learned, same we will use now also. So first is number of cubes we are trying to find out with 3 sides colored. With 3 sides colored. Now, what is the formula for number of cubes with 3 sides colored? 1 on each corner, correct? So that remains 8. Now, how many corners does a cuboid have? A cuboid, for example, if you look at this, this also has 8 corners. So cube or cuboid, it will always have 8 corners. So this remains same, this remains 8. Fine, then. Yeah, then next is this. After this 3 sides, now we look at 2 sides colored. Now 2 sides colored, how you used to find out? 2 sides colored used to be 1 or n minus 2 on each edge. N minus 2 on each edge. Now here what you will have is like this. N minus 2 on each edge, correct? Now this used to be multiplied by 12, correct? This is what it used to be. Why? Because all side lengths were equal. Now if side lengths are not equal, let's call the side lengths as A, B, C instead of n, or let's call them n1 into n3. It looks more intuitive to understand. So instead of n, instead of single n that was repeated thrice, now you have n1 into n3. So n minus 2 into 12 it used to be. Now what it will be? It will be n1 minus 2 into 4 plus, because 4 of the edges will come from this particular n1, correct? Now other will be n2 minus 2 into 4 and the third will be n3 minus 2 into 4. If I have to write all of them in short, can you see I can take 4 common in all of them? In all of them I can take 4 common and eventually I can get to this. So if I take 4 common, what I'll get? See, if I take 4 common, I will get n1 minus 2 plus n2 minus 2 plus n3 minus 2. That is n1 plus n2 plus n3 minus 2 minus 2 minus 2 minus 6. Okay, so now this is our formula that we need to remember. If you want to remember, usually we don't remember this and just expand it using the original formulas that we know for cubes. So this is for 2 sides painted. Now for 1 side colored. Now 1 side colored, how you will find? It is 1 side colored is n minus 2 whole square on each face, and you used to have 6 faces. So it used to be n minus 2 whole square into 6. But now it won't be like this. Why it won't be like this? Because the faces are not the same now. Now if you see, if I am trying to find out one of the faces, let's name them. Let's name this n1. This is n2 and let's say this is n3. Now what is this face area? This is actually n1 into n2, not n into n, correct? So here this length will be what? This length will be this length will be n1 minus 2 and this length will be n2 minus 2. Can you see this? So for this particular face, it will be actually what? It will be n1 minus 2 into n2 minus 2. Now how many faces we'll have like this? So one face I have like this here and one opposite to this. So this into 2. Fine. This into 2. Now next. Now similarly I can say that for this one, look, it will be n3 minus 2, this one will be n3 minus 2 and this will be again n1 minus 2. Can you see this rectangle which will be only one side painted? So again plus n1 minus 2 into n3 minus 2 into 2 and last will be plus n1 plus now whatever is remaining n2 minus 2 into n3 minus 2 into 2. This is what you will get. Understood? So I am removing this one. Now this becomes your formula for one side color. Understood? Just think of them logically. It used to be n minus 2 whole square into 6. Now you have two faces that are similar. So I broke down this n. So n1, n2, n1, n3, n2, n3 like this. So this becomes one side colored and the last is, which has also been asked, is no side colored. So no side colored, how many will you have? No side colored, original formula is what? Original formula is n minus 2 whole cube. Correct? Now, this was for when all ends were equal. Now all n, that is all side lengths are not equal. Now, so it will become, instead of n minus 2 whole cube, it will become n1 minus 2 into n2 minus 2 into n3 minus 2. This is the formula for no side color. This is the complete formulas of all of them. Got it? This is the formula for 3 sides colored, 2 sides colored, 1 side colored and no side colored. That's it. Now let's see a question from 2023 that was the most difficult from this chapter. Okay, now let's read the question. It says what? It says a cuboid of 7 into 5 into 3 centimeter is painted red, green and blue on each pair of opposite faces of dimension 7, 5 like this. Okay, so basically first thing that is given to us are these dimensions of the cuboid, 7 into 5 into 3 centimeters. So what is 7? So this is 7, correct? Then this one is 5 and this one is 3. So 7, 5 and 3. These are the 3 dimensions. Now it is said that it is painted as red on 7 into 5 wala side. So 7 into 5, this is painted red. Then it says it is painted green in 5 into 3 side. So 5 into 3, this is painted as green. Then next is 7 into 3 is painted as blue. So this is painted as blue. Okay, so these are the side lengths and their colors. Now it is saying then the cuboid is cut into 1 centimeter cubes. So first let's cut this into 1 centimeter cubes. How will I cut this? See. Now this is 7 length. 1 centimeter if I have to divide, then how many pieces I will make? I will have to make 7 pieces of 1 centimeter to cover the 7 centimeters. Now to make 7 pieces, how many cuts do I need to make? To make 7 pieces, how many cuts do I need to make? I need to make 6 cuts. So I'll be making 6 equal cuts in this direction. See how? So 1, 2, 3, 4, 5 and 6. Okay, little I'll have to move here. So this becomes 1, then 2, then 3, then 4, then 5, then 6. Like this. Can you see 7 parts? 1, 2, 3, 4, 5, 6, 7. So 7 parts I have made. Now, similarly, I will extend this. So this is extended here, 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 here. Now, how many cuts do I need to make on this side? This is 3 length. So 3 parts I have to divide. So I have to make how many cuts? I have to make 2 cuts. So I make 2 cuts, one here and one here. So this becomes 1 and 2. Okay, and extended here similarly 1 and 2. Okay, now this is 5 length, so I have to make 5 equal pieces. For that I need to make how many cuts? 4 cuts. So I'll make 4 cuts. So 1, 2, 3 and 4. These are the 4 cuts. So this becomes 1 and then 2 and then 3 and then 4. These are the 4 cuts. I'll extend it here also. So 1, 2, 3 and 4. Can you now see all the cubes? Correct? All cubes are now clearly visible. This was blue, this one was red and this one was green. Correct? These were the 3 colors. Let me write them in their colors only. Or let it be. Let it be. So this is green. Now, once you have drawn this I have to draw to explain you. Now see. First thing, it says, then the cuboid is cut into 1 centimeter small cubes. I have done that. Then, which of the following are correct? First, there are 15 small cubes with no paint. Now this you can find directly using our formula also. What was our formula? For no sides painted, in a cube, for no sides painted, the formula was n1 minus 2 into n2 minus 2 into n3 minus 2. Correct? N minus 2 whole cube. Instead, we have this. Now, what are the lengths n1, n2, n3? You know n1, n2, n3 are equivalent to what here? They are equivalent to 7, 5 and 3. So this is actually 7. This one is 5 and this one is 3. Correct? So 7, 5 and 3 are the 3 lengths. Now I put it here. So this becomes what? 7 minus 2, that is 5. This becomes 5 minus. This is 7 minus 2. Next is into 5 minus 2 into 3 minus 2. What you get? 7 minus 2 is 5. 5 into 3. 5 3s are 15. 15 into 1 is 15. So what you get? You get 15 only. So that means first statement is absolutely correct. That is, there are 15 small cubes with no paint. Now next one. There are 6 small cubes with exactly 2 faces painted, one blue and one green. Now this we have to observe. So what it wants? It wants cubes which have exactly 2 sides painted. One is blue, one is green. So you can find one here. Can you see this one? One is painted blue and the other is painted green. Okay. So one is painted blue and the other is painted green. This is fine. Now similarly you have one more here. Can you see this one? This one will also have one blue and one green. Now you will have one at the bottom also here and the last one more here by symmetry. So you will have 4 such cubes. Okay. Now can you see any other possibility of one blue and one green? No, because if you try to draw here, it will be one blue and one red, not one blue and one green. So there are 1, 2, 3, 4. Only 4 possibilities are there. Now, what does this statement say? This statement is saying that there are 6 small cubes. There are 6 small cubes with exactly 2 faces painted, one blue and one green. Is this correct? 6 small faces? No. 6 small cubes? No. The answer is actually 1, 2, 3, 4. So this statement becomes wrong because it should ideally be 4. It should ideally be 4 small cubes. So this statement is incorrect. First statement was correct. Answer becomes 1 only. That's it. Okay, so that's it for this chapter of cubes and cuboids. In the next one, we will see the chapter of dices. That's it. Thank you.